The LR-G200 integrated rebar scanner of Langrye is suitable for detecting the position of rebars, depth of concrete cover, and estimated diameter of rebars in reinforced concrete structures, and can accurately analyze the distribution of rebars. The scanner is designed as an integrated type for single-hand operations. It is equipped with a 3.2 inches touchscreen for easier operation and more intuitive display of measurement results. The scanner is adopted with combined detection method of high-power transmitting coil and multiple groups of small coils, providing multiple scanning modes for different detection environments. It supports detection of small and large ranges. This device is equipped with online management software that automatically generates 3D images for easier data management. 1. Instrument structure. The instrument box of the equipment includes host machine, accessories bag, etc. Among them, the host part mainly includes indicator, touchable LCD screen, buttons, USB interface, laser indicator, lithium battery. 2. System setting. Press the power button to start the machine. There are 4 functional units on main menu: rebar scanning, data display, system settings, and data deletion. The system settings function includes power saving setting, sound setting, date setting, scan settings, wireless system. Among them, pre-scan the stirrup spacing during field inspection. Set the parameters to 60, 80, 100, greater than 120 mm, according to the actual situation, and the scanner will make corresponding compensation when the reinforcement spacing is less than 80 mm. It is necessary to input data according to the average spacing of the detected structure. When the reinforcement spacing is more than 80 mm, it is necessary to set the parameters to greater than 80. If the depth of the concrete cover is within 100 mm, it is recommended to use small range. Otherwise, it is necessary to switch to large range mode. The rebar type includes threaded rebar and round rebar. Set the type according to the detected rebar. Please set other system options according to the need. 3. Scanning parameter setting. The rebar scanning interface includes 5 scanning modes: quick scanning, profile scanning, grid scanning, fine scanning, and image scanning. No matter which scanning mode is used, the scanning parameters need to be set first. 1. Object name. The object name consists of number, letter, symbol. Please set it as required. 2. Designed diameter. It is for setting the diameter of detected rebar. The diameter can be set from 6 to 50, involving 15 kinds of rebar specifications. In both grid and image scanning modes, both lateral and longitudinal diameters need to be set. 3. Design depth. It is for setting the design depth of concrete cover of the detected rebar, which can be set from 1 to 205 mm. In both grid and image scanning modes, the design depth of X and Y directions need to be set. 4. Structure type. You can choose 2 structure types: beam and slab. After the scanning parameters are set, click on the scan, and the device prompts that the device self-calibration will be carried out first. At this time, it is necessary to lift the instrument in the mid-air, keep it away from metal objects, and then press the OK button to start calibration. Detection can begin when the screen displays calibration completed. 4. Scanning mode. Quick scanning. The specific scanning steps are as follows. Move the rebar scanner slowly and uniformly to the right for scanning. When the rebar scanner is close to the rebar, a green aiming box appears on the screen. When the green aiming box coincides with the center line, it will turn red. The red indicator light turns on. It means there's a rebar here. When you move the rebar scanner to detect another rebar, the instrument will prompt as above. The depth of concrete cover and the spacing from the previous rebar will be displayed, such as the current concrete cover is 26 mm thick, the concrete cover of the previous rebar is 26 mm thick, and the spacing between the two rebars is 109 mm. During the measurement, press the 3-point button on the upper right corner to view the current rebar diameter and the depth of the concrete cover. 5. Scanning mode. Profile scanning. Profile scanning is to display the position of the measured steel bar, the thickness of the protective layer, and other information in the form of longitudinal section distribution map. The central solid line is the design datum line formed by inputting the designed depth value before the detection, and the dotted lines above and below the datum line are the positive and negative deviation lines specified in the regulation. The detection data beyond this range are considered as unqualified data. This is similar to the quick scanning. 6. Scanning mode. Fine scanning. The fine scanning mode displays the waveform, position of rebar, depth of concrete cover and other information of the detected rebars in the form of a waveform diagram. When fine scanning interface appears, move slowly to the right for starting measurement. The screen will display the signal waveform and display the real-time displacement value at lower part of the screen. When the instrument approaches the rebar, the signal value starts to increase, and the waveform curve slowly increases. When the instrument is away from the rebar, the waveform curve decreases slowly, and a wave peak appears. A white line will be displayed at the peak, indicating that there is a rebar here, and the thickness of reinforcement protective layer will be displayed above the peak. Rebar spacing is shown below the peak. The fine scanning mode supports a maximum scanning distance of 10 meters, and the scanning process should be slow and constant. Dense scanning is designed specifically for dense rebars. In fine scanning mode, press down button to enter dense rebar mode. When there's an abnormal rebar, you can manually delete the rebar measuring point by pressing the FN button. 7. Scanning mode. Grid scanning. The grid scanning shows the position of detected rebar, the depth of concrete cover, and spacing between rebars in the form of a grid diagram. Under grid scanning, perform the horizontal scanning first. When the rebars in the horizontal direction are already scanned, press the OK button to switch to the vertical scanning. The distribution of rebars can be clearly seen by grid scanning. After the scanning is completed, press the C button to save the data and exit. 8. Scanning mode. Image scanning. The image scanning mode combines fine scanning and grid scanning to perform comprehensive analysis through multiple scanning in horizontal and vertical directions within a specific area, which is suitable for irregular distribution of rebars. In the image scanning, a maximum of 5 by 5 grid area can be scanned. The procedure is 5 horizontal scans, 5 vertical scans. The scanning sequence can be selected at will. After the scanned data is imported into the computer, the analysis software can generate the data into 3D graphics for visual view of the rebar distribution. 9. Other functions. 1. Data viewing. The data viewing unit is mainly for viewing the detection data of each detected structure, and data stored in the rebar scanner. The instrument provides 2 data viewing methods: graphics and list. 2. Data deletion. Data deletion function mainly enables manual data deletion. Note: the data deleted cannot be recovered. Please operate with care. 10. Online system software. The software is a multifunctional analysis software for data processing of rebar protective layer, and it is easy to operate. First, connect the rebar scanner to the computer with a data cable, and then turn on the rebar scanner. Open the online system software. Click the menu Rebar Scanner. Click Import automatically. The software will import the data in the steel bar instrument. After that, we can do data processing on all the components. Click Detected Component Data in the tree diagram to modify and improve the data. Click Data Processing, then click Generate Report. The software will automatically generate the test report. We can preview and print the report.